Okay guys, in this video we're just going to be looking at polynomial functions, and so let's go ahead and quickly review what we mean by a polynomial function. Poly, just meaning many here, is basically a many named function or a function having many different terms. And so just to be clear on this, remember that polynomial functions have many different terms that are being added together with one another. And this polynomial could have many terms or it could have one term, but the stipulations are these. We say that all of these coefficients, these numbers that we're taking times x here, okay, they all have to be real numbers. And furthermore, we say that all of the exponents on our x's here, they would have to be non-negative whole numbers. So if that's the case, then we would have what we say is some polynomial function of degree n here, where n is our highest exponent on the polynomial, and our leading coefficient is this a sub n out in front. And so as I've got this written here, or as it is written here, you'll notice that the exponents are going in decreasing order. That tends to be the, I guess, the convention in math is to write those in decreasing order, and we'll refer to that as standard form. So what I'm interested in doing actually in this is just identifying which functions over here on the left are actually polynomials, and furthermore, what their degree and leading coefficient would be. And so looking at this, I guess we just want to find the degree, but I'm going to ask you for both here. So for looking at these, say number one here, we say, is this a polynomial function? Well, here's the stipulation. We need all of our coefficients here to be real numbers. And as I observe it here, there are no i's involved. So those are all real numbers, so it checks out. And then the next stipulation was that all of our exponents have to be non-negative whole numbers. Okay, so non-negative whole numbers here, we would see that our 2 here and 3 are definitely non-negative, and they are whole numbers. And so this would actually be considered a polynomial function. And so we would write that. We say this is a polynomial function, not just any function, because it has non-negative coefficient, or non-imaginary coefficients and non-negative whole number exponents here. So the thing we wanted to do is identify the degree, here. So I'm going to do this really quickly here. Not that it's a necessity, but I'm going to rewrite the order of this so that it's 6x cubed plus 5x squared. And just because I want this to be in decreasing exponent order, but to identify the leading coefficient in the degree, this would be really easy for us now. We can say the leading coefficient is actually equal to 6, and then our degree here. Our degree is the highest exponent on any variable term, and so we get third. So looking at this third, we actually give this a name. I'm going to give it its name. I actually started to write it right there. That's supposed to be a parenthesis. We say it's a cubic. Okay, so why is it a cubic? Well, third degree things, we refer to these things as being cubics because 3 is the highest exponent on it. Whereas, 0, 1, and 2, if we say those are the degrees here. With the 0th degree thing, I think it's important to note that our function is just a sub 0 times x to the 0. And so I'm going to write the 0 power rule here. We say 0 power rule. But I want us to know that anything to the 0 power is going to be equal to 1 unless x is equal to 0, so we don't allow x to be 0 to the 0 here. It would be bad. But we would say a constant thing here is 0th degree. Okay, a linear thing is mx plus b, basically y equals mx plus b, but it's a first degree polynomial. Or second degree polynomial is quadratic. These are these graphs of parabolas. And then third degree cubic, fourth degree quartic, and fifth degree technically is a quintic. So looking back over here at our polynomials, we're looking for things that exist as having non-negative whole number exponents and real number coefficients. We say, well, what do you think about number 3 here? So looking at all of our coefficients here, basically they're all real. Do you see any i's is the question you need to ask yourself. And so you don't see any i's there, so that would actually check out. And then the other thing we're looking for is non-negative whole number exponents here. And so I look at 5, that's non-negative whole, 3 is non-negative whole, and this would be a 1 non-negative whole. So this would be a polynomial function. We would say that this is indeed a polynomial function. And what we want to know is what's the leading coefficient, what's the degree. So at least for g of x here, this is already in standard form. I'm not going to rewrite it, but we'd say that the leading coefficient here, our coefficient that leads the front here would just be a 7, and then our degree here, the highest exponent. Looks like we have a quintic or a 5th degree thing. Okay, so now we look at number 5. And number 5, a little bit different here. Do you see anything that's different about number 5? And how do we feel about this? Is it a polynomial or not? Well, definitely we've got some non-imaginary coefficients here. This is an odd coefficient to have, but it's kind of up on top of our fraction there. But our exponents here, the tricky thing is that we have whole number non-negative exponents here, but this x, this 1 over x, we are going to write the negative exponent rule over here. And this is a rule that we'll want to get used to soonish. but we'd say the negative exponent rule says that anything to a negative exponent here would be the same thing as if you had moved the base that the exponent's attached to across the other side of a fraction bar. So we would, if we were to take the base of this negative exponent and move it to the bottom of the fraction, all of a sudden its exponent would become positive, and so we would get the reciprocal of this thing right here. And so that being said, what I want everybody to recognize is that 1 over x then would have to be the same thing as x to the negative 1. So I'm actually going to rewrite this polynomial up here. We're going to say this is 7x cubed plus 2x squared, and I think this would be a good idea, plus x to the negative 1. And the reason why I want to write this is because if this negative 1 right here, we would not have a polynomial function. So it's not a polynomial. Okay. And then last but not least, we say like something like number 7 here. If we had x to the 1/2 power minus 3x squared plus 5, x to the 1/2 power is a little bit different than anything we've ever seen up here. It's definitely not negative, but it's not a whole number. So really quickly, I will point this out here. When we say x to the 1/2, that's kind of the same thing as saying the square root of x, because we're saying x to the first power, the square root of that. But that definitely is not something that we would have in a polynomial function here. We have very well-behaved functions. So this is not a polynomial function, and the reason why it's not a polynomial function is because we have a non-whole number exponent. So be looking out for those things, and also identifying polynomials, write them in a standard form, be able to identify the leading coefficient degree. Cheers.